Hello, this is Garth Wiley from 6DOF Testing and Analysis. Today, we're going to be talking about field testing approaches to product structural validation. And these approaches are really based on our experience over the years. This video is a part of a series of videos on product structural validation. The particular approach can depend on the industry. This is certainly not all inclusive, but it is again based on our experiences over the years. And very often in these programs, we are partnering with our customers, sometimes providing training, sometimes essentially using our customers' people to help reduce the budgets and so forth. The uh, nature of the product and the particular situation often involves adapting these approaches. So it's not really a particularly cookie cutter approach. It's just meant to be showing you an example in this case of how we would use field test validation. And this may be applied to a wide range of products, often vehicles of some type, whether they be farm equipment, construction equipment, rail equipment, trucks, specialty vehicles, and so forth. Generally, our customers handle the product design, the CAD model development and simulation that's involved in evaluating different loads on the structure and so forth. And our role generally is in the validation process. However, sometimes the loads that are really needed at the design phase when the product is being developed are not well known. And if that is the case, there is work that could be done in front of the design process to give us an idea of what the duty cycle environment, what the loading environment is, and particularly looking for what might be large, unusual loads, sometimes with data gathered over a long period of time. So we have some techniques for putting measurement systems on vehicles. They can go out in the field into whatever operating condition they may normally run for. And we can take data for days or even months to completely document the entire duty cycle. And depending on the nature of the testing, sometimes this equipment is highly ruggedized, depending on the environment that the product will be in. As part of the test planning, we use the finite element model to help us locate strain gauges and other instrumentation. So we will apply loads like inertial loads, twist loads, or any other specific loads that may relate to an important operating condition. And although these loads may not be the actual loads that the structure sees in operation, they will, in all likelihood, show us the hot spots. They will guide us to the best locations to put our strain gauges. Because if our strain gauges are not in the right locations, they don't do us that much good. In addition to strain gauge location, other things can be done to measure loads, for example. Parts can be turned into transducers. And this, of course, depends on the nature of the part and so forth, but they can be instrumented and calibrated to directly output forces. And in addition to strain gauges, we may strain gauge bolts because all of the connections on the structure are very important. And sometimes we may want to put gauges on a bolt to measure its tension and bending loads as a part of an evaluation of that bolt-to-joint connection. And furthermore, the gauge locations, they often are going to be near welds. And so the welded joint areas are areas that we want to pay particular attention to in making sure that we have stresses in those ranges that are suitable based on welding standard curves and so forth. And then a part of the test planning, we'll also be defining test events. And we need to consider the full range of product configurations and the full range of product weights with payload, without payload, and so forth. And sometimes the without payload condition can be an important condition. Our field validation testing can be basically broken up into two types of activities: staged events and typical operation. Staged events, for example, might be a twist load put on the structure, or perhaps loading the structure from empty to full while recording the stress and strain data. The typical operation would be just that, but should be conducted over a range of, if it's a vehicle, speeds, over a range of loading conditions, and so forth. And we would be including all of the duty cycle events that we may have measured way up front and defined at the very beginning of the design process. So all of this data can be collected together, and there are a couple options, by the way, in how we can record this data. Sometimes for our customers, they would just like us to take care of the entire process. But sometimes we can do what we call an assisted test. And that's where we develop a test package that may have a PC located in the package and a modem to allow us to communicate with the package, shipped to the customer, and the customer takes data on site. And we can control the system over the internet. And so the customer doesn't really have to know how to run all the test equipment, but they kind of become our hands on site. And so this is an approach that works in certain situations with where we have some very good planning. There's a wide range of ways to evaluate the measured data, particularly the stresses. Sometimes we just start by looking at the time histories of all the different events and getting a sense for the strain levels, and then computing stresses and looking at stress ranges for and ranking them according to events. And if it's a welded structure and we have gauges near the welds, we pay particularly close attention to the stress ranges that we're seeing and comparing that to the various welding institute curves and so forth, depending on the type of the weld. We can also look at the data from somewhat of a statistical standpoint and be particularly interested in perhaps some rare large events. And sometimes these can be very significant. The fatigue damage of a continuing number of large events can add up fairly quickly, even though the number of events isn't huge. And so much of the data that we'll be examining, we'll be looking at it from a fatigue standpoint. One other thing that we may do could be using the model to help us out a little bit. Let's say we could not locate a strain gauge in a particular area we are highly interested in, but we're able to get gauges nearby. We can use the model to give us some feeling of what the extrapolated or interpolated stress might be from our measurements. Sometimes this gets pretty complicated, but nonetheless, it's not always possible to make a measurement to locate a strain gauge in a particular location that we're most interested in. And so we can actually use the model to help us understand some of this data and to interpolate. So essentially this entire approach is very integrated with the simulation. And so the simulation, as we said, places a big role in the planning of the testing, and it helps us to interpret some of the test data. And then some of our staged events actually help us to gain confidence in the model. So thank you very much for listening. If you have any questions, please contact 6DOF Testing and Analysis. By the way, this is our website, and here's our email address and our phone number. So once again, thank you for listening.